I'm fascinated by one simple question. If humans are mammals like every other ape, why do we look so different when it comes to hair? Chimpanzees, gorillas, and orangutans wear a thick coat from head to toe, while we spend time styling, washing, cutting, coloring, and even worrying about the hair growing on a single part of our bodies. That contrast isn't just cosmetic. It's the result of one of evolution's most remarkable engineering projects, a story that stretches back millions of years and reveals how our ancestors survived some of Earth's harshest environments. At first glance, human skin appears almost hairless, but that's actually an illusion. Our bodies still contain millions of hair follicles, nearly as many as our closest primate relatives. The real difference is what those follicles produce. Instead of thick, insulating fur, most of our follicles create tiny, soft hairs that are difficult to notice. Only a few regions, especially the scalp, continue producing the long, thick strands we associate with human hair. It's a reminder that evolution rarely starts over from scratch. More often, it repurposes what already exists. Nature didn't remove our hair-producing machinery. It simply adjusted how that machinery worked to solve new challenges. If you've ever wondered why humans spend so much time thinking about hair, comment 1. You might be surprised to learn that the answer began long before mirrors, salons, or shampoo ever existed. To understand why our bodies changed, imagine traveling back more than 1 million years. Early human ancestors were leaving dense forests behind and entering vast African grasslands. The environment had transformed dramatically. Shade became scarce. Temperatures soared during the day, and finding food often meant traveling long distances beneath an unforgiving sun. For an animal wrapped in thick fur, that landscape presented a serious problem. Fur is excellent at trapping warmth, which is valuable in cooler forests. But under intense heat, the same insulation becomes a burden. Every step generates body heat, and if that heat cannot escape, survival quickly becomes much harder. Our ancestors gradually developed a different strategy. Instead of relying on fur for protection, they became masters of cooling themselves. Humans possess an extraordinary number of sweat glands spread across nearly the entire body. When sweat evaporates, it removes heat from the skin with impressive efficiency, allowing us to stay active even when temperatures climb. That simple ability changed everything. While many animals can sprint faster than humans, few can continue moving for hours in extreme heat without overheating. Early humans turned endurance into an advantage. Rather than catching prey through explosive speed, they could keep following it until the animal became exhausted by the heat. Persistence often proved more valuable than raw power. Success doesn't always belong to the fastest competitor. Sometimes it belongs to the one who can keep going after everyone else has stopped. Evolution teaches the same lesson that life often does. Endurance quietly defeats brilliance when brilliance cannot last. Scientists have proposed additional ideas that may have influenced the loss of body hair. One possibility is that having less fur made it more difficult for parasites like lice, ticks, and mites to thrive. Fewer parasites could have meant fewer infections and better health, giving less hairy individuals a slight survival advantage over many generations. Another consequence followed naturally. Once thick fur disappeared, skin became directly exposed to intense sunlight. That increased the importance of melanin, the pigment that helps shield the body from harmful ultraviolet radiation. this way, changes in hair and skin may have evolved together as part of the same long adaptation. Not every explanation has equal scientific support. Some researchers have suggested that human ancestors spent significant time in aquatic environments, where reduced body hair might have improved swimming. While this idea remains popular in some discussions, most experts consider the evidence too limited to place it alongside the stronger explanations involving heat regulation and parasite pressure. Science often moves forward by comparing multiple ideas instead of accepting the first one that sounds convincing. The willingness to question, test, and revise is one of humanity's greatest strengths. Now comes the real mystery. If body hair became less useful, why didn't all hair disappear? Why would evolution reduce fur almost everywhere while preserving a thick layer on top of the head? The answer may lie inside the organ, hidden just beneath it. Our brains are remarkably expensive tissues. Although they account for only a small percentage of our total body weight, they consume an enormous share of our energy and function best within a narrow temperature range. Even modest increases in brain temperature can reduce mental performance. Standing upright also changed our exposure to the environment. The highest point of the body became the top of the skull, placing the brain directly beneath the strongest sunlight during the hottest hours of the day. Instead of covering the entire body with insulating fur, evolution appears to have concentrated protection where it mattered most. Scalp hair acts like a lightweight canopy, intercepting much of the sun's energy before it reaches the skull while still allowing air to circulate. Modern experiments support this remarkable idea. Researchers have found that hair on the scalp reduces heat absorbed from sunlight and lowers the amount of sweat required to keep the head cool. In other words, your hair isn't simply decoration. It continues performing a practical job that helped our ancestors survive under conditions that would have challenged many other mammals. The next surprise is even more fascinating. Not all hair textures perform this task equally, and understanding why opens another chapter in the story of human evolution. One of the most fascinating discoveries in recent years is that hair texture can influence how effectively the scalp handles heat. Hair that forms tight coils naturally stands away from the surface of the head, creating a layer of air between the scalp and the outer strands. That space acts like a protective cushion, reducing the amount of solar heat that reaches the skull while still allowing air to circulate. Straight hair behaves differently. Because it rests closer to the scalp, heat can be transferred more directly. Wavy hair falls somewhere in between. Each texture represents a different solution shaped by the environments where human populations lived over thousands of generations. As early humans gradually spread beyond Africa into regions with cooler temperatures and less intense sunlight, the pressures of natural selection also changed. Hair no longer needed to solve exactly the same problem everywhere. Over countless generations, new textures, thicknesses, and growth patterns appeared, each reflecting local climates and unique evolutionary histories. The incredible diversity of human hair is a reminder that difference is not a flaw. It is evidence of adaptation. Every feature carries a story written by countless generations who survived challenges we can only imagine. Comment 2. If this changes the way you think about your own hair. Another mystery remains. Why does human scalp hair keep growing for years, while the hair on your arms, legs, or eyebrows stops after reaching a certain length? The answer lies in the hair growth cycle. Every follicle passes through phases of growth, rest, and renewal. On most parts of the body, the active growth phase is relatively short, producing only a few centimeters of hair before growth pauses. Scalp follicles operate under a completely different schedule. Their growth phase can last several years, allowing hair to reach extraordinary lengths before naturally shedding and beginning a new cycle. That unusually long growth period is rare among mammals and helps explain why humans need regular haircuts, while wolves, gorillas, and countless other animals never do. Scientists believe this feature may have offered advantages beyond protecting the brain from sunlight. Long, healthy hair can reveal valuable information about an individual's overall condition. Maintaining strong hair over many years requires sufficient nutrition, healthy hormones, and a well-functioning body. In evolutionary terms, hair became a visible indicator of health long before modern medicine existed. Across cultures and throughout history, people have decorated, braided, cut, covered, or styled their hair in countless ways. While beauty standards differ widely, our attention to hair may have deep biological roots that stretch back hundreds of thousands of years. Hair also serves as a surprisingly honest record of aging. The pigment-producing cells inside each follicle gradually become less active over time. As they produce less melanin, newly growing hairs appear gray and eventually white. In many ways, every strand quietly records the passage of time. Perhaps that's one reason so many people invest in coloring, conditioning, or caring for their hair. We are not simply changing our appearance. We are responding to signals that evolution has taught humans to notice for an incredibly long time. Sometimes the smallest details become the loudest forms of communication. Before we ever speak, parts of our biology are already telling a story. Yet another overlooked feature deserves attention. Look closely at your arms under bright light. You'll notice countless tiny hairs covering the skin. They seem almost useless because they provide little warmth and are barely visible. But appearances can be deceiving. Each of these fine hairs connects to sensitive nerve endings beneath the skin. Even a slight movement bends the hair, triggering those receptors before something actually touches the surface of your body. In effect, these tiny hairs expand your sense of touch, giving you an earlier warning when insects or other small objects move across your skin. Rather than being leftovers from our furry ancestors, these delicate hairs continue serving a practical purpose. Evolution simply reduced their size while preserving their usefulness. When we step back and view the entire picture, human hair begins to make remarkable sense. We lost thick body fur, so our sweat could cool us efficiently during long periods of activity in hot environments. We retained dense scalp hair to shield our brains from intense sunlight. Different climates encouraged different hair textures, each adapted to local conditions. Long growth cycles transformed hair into a powerful signal of health and identity, while nearly invisible body hair continued functioning as part of an incredibly sensitive detection system. Every strand reflects millions of years of problem solving. The next time you're frustrated by a bad hair day, remember that your hair exists because it helped countless generations survive. It protected vulnerable brains from scorching sunlight, helped regulate body temperature, communicated health, enhanced sensory awareness, and eventually became one of humanity's most recognizable forms of personal expression. What feels like an ordinary part of your appearance is actually a living record of evolution, one that connects you to ancestors who crossed open landscapes, adapted to changing climates, and passed those remarkable solutions from one generation to the next. Comment 3. If you'll never look at human hair the same way again.